All right, so here's our lesson on graphing systems of equations. So we're going to take what we were doing last unit and take it to the next level, where instead of just saying one equation at a time, we're going to have two or three, and we're trying to find a solution that will work for all of them. So we're going to start with some vocabulary, so you might need your highlighter here. So a system of equations, when we're finding the solution to the system, is just a point of intersection. Where do those graphs go together? And the answer, the solution, is that ordered pair that makes all of the equations true. It could be 1 point, it could be more than 1 point, it could be no points. It just depends on the situation. Okay? So similar to solving an equation, it's possible to have one solution, an infinite number, so all solutions, or no solutions. So some new vocabulary for us is a system of equations is consistent. Okay? That means it has at least one solution. So that means one or more. It is an independent if it has exactly one solution. So consistent could have one or more. Independent is specifically one solution. A dependent system has an infinite number of solutions. So there is an unlimited number of ordered pairs of coordinates that could make this system be true. And then inconsistent is one that has no solutions. So consistent means it has one or more. Inconsistent means it has none. Independent means it has exactly one solution. Dependent means it has an infinite number. They kind of depend on each other. And then inconsistent is one that has no solutions, meaning the graphs are parallel to each other. So those lines are running parallel, so they're never going to cross, so there's never a point that's going to work in both of those. All right, so let's see what that looks like here. So in the first column, we have one solution. Okay, so we have two lines that are graphed. You'll notice that the slopes are different, and the y-intercepts are different. So they're both moving at different angles, and they cross the y-axis at different points. So they have one solution, so they are consistent, meaning one or more solutions, and independent, meaning they have exactly one solution. Now we look at ones that are parallel to each other. So you'll notice that the slopes are the same, they're equal to each other, but the y-intercepts are different. So they cross the y-axis at different points, but they're both headed in the same direction, meaning, unfortunately, there's not going to be any solution that makes this true. So this is an inconsistent system of equations. They're never going to intersect. They are never going to have a solution. And then we have our last one with our infinite solutions. So all solutions for this one. You'll notice here, you'll only see one line because they're right on top of each other, because they're both the same line. The slopes are the same, and the y-intercepts are the same. Okay? They're literally the exact same line, meaning every possible solution. So every point along there is going to be a solution to both of those. So we call it consistent because it has one or more solutions, but it is dependent because it has an infinite number of solutions instead of exactly one. All right, so we're going to put this to use for two problems real quick. So we have two equations, y equals 3x minus 4 and y equals negative 3x plus 2. So we're going to identify some key information. So first we want the slope of each of them. Well, the slope of the first one is 3. The slope of the second one is negative 3. The y-intercept is going to be negative 4 and 2. So are the y-intercepts the same or different? They are different. So when the slopes are different and the y-intercepts are different, this is going to have exactly one solution. Okay? So now we're going to go ahead and graph it. So I'm going to start with 3x minus 4. So I'm going to start at negative 4, and I'm going to go up 3 up 3 and over 1. And I'm going to graph those points. I can go in the reverse. And then I draw my line all the way through it. Now I'm going to do the same for my second equation. It's got a y-intercept of 2. And then it has a slope of -3. So that's -3 over 1. So down 3 over 1. So I'm going to graph that, and I can graph in the opposite direction. And then I draw that line. You'll notice that they intersect at this point here, the point 1, -1. That's my solution, the coordinates for the point where it intersects. So my solution is 1, -1, but we're going to check it. If that's true, it should be a solution to both of these equations. So I'm going to put in -1 for y. I'm going to put in 1 for x. 3 times 1 is 3, minus 1 is -1. -1 is equal to -1, so I'm good. Now I'm going to check it in the second one. I'm going to put in -1 for x. I'm going to put in +1 for y, or sorry, +1 for x, -1 for y. -3 times 1 is -3, plus 2 is -1. -1 is equal to -1, so I am good. I've checked that those two equations do have one -1 as a solution. All right, second one. So you'll notice for the first one, it's pretty easy to find my slope, 4/3. But for the second one, it's not in slope-intercept form, so I'm going to need to do a little solving. So I'm going to rewrite it in slope-intercept form. So I get 3y is equal to -2x minus 9. Divide everything by 3. And I get y is equal to -2/3 x minus 3. Here, my slope is going to be -2/3, so they have different slopes. My y-intercept in one is +3, it's -3 in the other, so they have different y-intercepts. So different slopes, different y-intercepts, so two completely different lines, they're going to have one solution. So now we're going to go ahead and graph those two equations. So I'm going to start with 4/3 x plus 3. So I'm going to go up to +3. 4/3 means up 4 over 3, or down 4, left 3. And then I'm going to draw my line through my points. These are ones where you're going to want to use a ruler to make sure we get it drawn as carefully as we can to make sure we find where those are going to intercept. So here I get y equals -2/3 x minus 3. I want to graph y equals -2/3 x minus 3, so I'm going to go down to -3. My slope is -2/3, so down to right 3, down to right 3, or up to left 3. I'm going to graph both of those lines. Remember, the line should be drawn all the way through your coordinate grid. And then we look to see where they intersect. They intersect at the point -3, -1. So I write that as my ordered pair. And then I'm going to go ahead and check my solution. I'm going to make sure I've done it correctly. So I'm going to put in -1 for y. I'm going to put in -3 for x. 4/3 times -3. Well, my 3's are going to cancel, so I'm going to get -4 plus 3, which is -1. That is equal to -1. And then I'm going to do the same thing with my other one. I'm going to put in -3 for x. I'm going to put in -1 for y. 2 times -3 is -6. 2 times -1 is -3 times -1 is -3. That does give me -9, so I am good. So that's how we're going to be graphing our systems of equations. Okay, checking to see, do they have the same slope? Do they have the same y-intercepts? That lets us know how many solutions we should be looking for. Then we graph the two lines to see where they intersect, and then check our solution.